Porsche 918 Spyder's V8 engine is coupled to dynamic hybrid modules. They not only allow the car to operate electrically, they also convert kinetic braking energy into reusable electricity. Assembling a hybrid module starts with the magnet AC synchronous motor, made up of a stator and a rotor. The stator consists of wound conductors and armature framework. Select small coils with copper winding wires attached to the circular armature. Each coil mounts onto the lamination stack, which includes the stator and rotor core. Every coil is made of 50 windings of copper wire, plastic end caps, and isolation paper. Each coil automatically becomes part of the rotated stack. The coils mount precisely to the stack to generate the necessary charge. When complete, the lamination stack consists of over 200 sheets of metal. The armature moves slowly into a brazing station. Copper wire ends join the interconnectors through a high-temperature fusion process. The electric interconnection of the coils is established by brazing the two copper wires of each coil at almost 800 degrees. Plasma-activated silicone is applied to securely insulate the interconnection. To ensure its cohesion, an automated device delivers low-temperature plasma, creating a thermoplastic layer. This is the silicone in its liquid state. The next part of the process is called trickle impregnation. The armature revolves on an auto-centering chuck. As it rotates, a series of drippers apply insulating resin to the windings at controlled rates. In the final stages of the motor's assembly, the armature, the electric metal sheets, and coils mount onto a base carrier. Once they lock into position, the air guide frame lowers into the armature. The outer frame aids in the air ventilation paths between parts and soundproof enclosure during operation. The current connecting slip rings end cover completes the manufacturing of the stator unit. A small sealing robot accurately positions and dispenses resin onto the rotor's encasement. It can control all aspects of application parameters such as fluid flow and speed proportional control. One at a time, a specialist places magnets into the main clutch of a positioning jig. The jig's compression vise aligns and firmly attaches the magnet to the heavy-duty resin on the rotor case. Within AC synchronous motors, magnetic fields form in both the rotor and the stator, producing a torque on the motor shaft. This is the union of the rotor and the stator. This bearing bracket creates a clearance gap between the two elements. The bracket maintains even spacing between the parts through the 360 degrees of rotation. The specialist adds the housing, power terminal, and cables. The terminal manages the power field as electricity flows from the battery to the electric motor. Like most electric and hybrid cars with a high-voltage electrical system, cables and connectors are colored bright orange for safety.